Good morning. Welcome to class 9 Physics ICSE. We are continuing with our second chapter in physics, that is motion in one dimension, and now we are coming to equations of motion. We have already learned there are three equations of motion. First one, V is equal to U plus AT. Second one is S equal to ut plus half at square, and the third one, v square is equal to u square plus 2as. We already learned how to derive these relations. In each one of them we have u, v, a, t and s, the variables. U stands for initial velocity, v stands for final velocity, a stands for acceleration, t stands for time in seconds, and s is the displacement. Let us look at our first question. A body starts from rest. Whenever we hear about starting from rest, what does it tell you? That initial velocity is 0. So let's continue. It starts from rest with a uniform acceleration and attains a velocity of 10 meter per second in 2 seconds. Find its acceleration. Anytime we have these problems, first thing you should do is understand which are the quantities involved in this. It starts from rest, means initial velocity is 0 meter per second. It attains the velocity of 10 meter per second, so that is the final velocity, 10 meter per second, and in 2 seconds, so that is your time, and they are asking you find its acceleration. We have u, v, t and a, so we are looking at first relation. So using v is equal to u plus at, 10 will be equal to initial velocity 0 plus a is, we do not know, and t is 2. So you will have 10 equal to 2a, and a will be equal to 10 upon 2, and we have a equal to 2 ones and 2 fives. It will be 5 meter per second square. You can see this 10 is actually 10 meter per second, and 2 is the second which has come here, and then you get your answer as 5 meter per second square, and that is our answer 1. We will write here acceleration. Let us come to our second question. A body starts from rest. Now, you are right. Starts from rest means what? Initial velocity 0. With a uniform acceleration of 5 meter per second square, and this is another quantity given, for 4 seconds. What is 4 seconds now? Time. And then you have to find the distance. So let us write down for the clarity of thought. Starts from rest means initial velocity 0 meter per second, and it is traveling with a uniform acceleration. So a has been given as 5 meter per second square. For 4 seconds means time is given, and they are saying find the distance traveled. So s is equal to question mark. The relation between u, a, t and s, if you can look over there, which is the relation? That's right, the second one. S is equal to ut plus half at square. U we have, a we have, t we have, and s is to be found out. So let us write the relation. We will say using can we substitute? S we do not know. Ut is 0 multiplied by 4 plus half. A is 5 multiplied by t square is 4 into 4. So you will have 2 going twice over here, and this is 0 plus 5 is 10 and 4 is 40. So you will have 40 meters. And that is our answer 2. This is our distance travelled. Let us come to the next question, that is question 3. A body with uniform acceleration, and the acceleration is 7 meter per second square, changes the velocity from 6 meter per second to 8 meter per second, and find the distance. Let us write the quantities. Acceleration is given as 7 meter per second square. Changes the velocity from 6 to 8, so initial velocity. So it will be changing the velocity. Initial velocity is 6 meter per second, and the final velocity is 8 meter per second. Which is the formula that has A, U, V and S? That's right, is the third one. Let us write it down. V square is equal to U square plus 2AS. V square is 8 square. U square is 6 square plus 2 into 7 into S. So it will give us, therefore, 64 is equal to 36 plus 14S. Bring 36 this side. So it becomes, therefore, 64 minus 36 is equal to 14S. So you will get 28 is equal to 14S, and S will be therefore equal to 28 upon 14. Therefore S, which is the distance travelled by it, is 14 ones and 14 twos. So it is 2 meter, and that is our answer. Let us now come to our last question. Question 4. A bullet is moving with the initial velocity of 30 meter per second, comes to rest after striking the target and penetrates 15 centimeter in it. Calculate its retardation. So you see, as we read, we check with the quantities that are presented there. So we have initial velocity. We already know that initial velocity is called as U. So U is 30 meter per second. Comes to rest, which means the final velocity is how much? After striking the target and it goes into the target 15 centimeters, so that becomes the distance travelled by it. So that becomes 15 centimeter. But we can't keep it centimeter because everything else is in SI system. So you have to make it 15 upon 100 and keep it like so. Calculate the retardation. Now retardation means first I'll have to find acceleration and then I will write it as retardation. Which is the formula with U, V, S and A? The last one. So we will write it. V square is equal to U square plus 2AS. V square is 0. 0 square is equal to 30 square plus 2. A we do not know, and S is 15 upon 100. Therefore, 0 is equal to 900 plus 2A into 15 upon 100. Bring 900 this side. So it becomes, therefore 900 becomes minus 900 is equal to 2A into 15 upon 100, and therefore you will have A equal to minus 900 into 100 upon 2 into 15. Now 15 goes 6 times in 90, so 660 times in 900, and 2 will go in 3 times, so this will be 30, and therefore acceleration will be minus 3000 meter per second square. But they are asking us for retardation. So you will write, therefore retardation, which is equal to minus acceleration, will be minus into bracket minus, how much it is? 3000. So minus 3000 meter per second square, and that will give us positive retardation, and that is our answer. Answer for the fourth one. So you see, we have used different numericals to understand the use of the formulas. V is equal to U plus AT, S is equal to UT plus half AT square, and the third one, V square is equal to U square plus 2AS. So this, I hope, gives you confidence to use these formulas and follow the further numericals and to solve them. Thank you for watching.